Did you like the rain yesterday that, knocked down some of that pollen? I don't know about you. That's like, I'm like, normally you'd be like, oh, it's raining. I'm like, oh, please, just a little more. Actually, it's more like, please, just a little more. But, oh man, that stuff tears me up. Although it's actually where the like ragweed and all the other stuff that's coming up, that's the stuff that really hits my allergies. Oh my gosh. What other random small talk do I have while I'm trying to burn time? Let's see. I went and watched Shazam last night. That was good. So, did anybody here ever watch the TV series Chuck? Yeah? Yeah, it is pretty old now, yeah. But I'll give it just another minute or two. I don't know if people are strolling in or not, but today's going to be pretty light on code. Well, except for this last little section here. We'll probably finish the video portion early, so if people want, again, to work through some of the problems on the assignments, then I'll be able to sit down and hopefully help work through some of that stuff, just like we did in the last class. I don't have any deadline to get out of here today, because I've got nothing else going on, so I can hang out as long as people need me. Yeah, today, for the most part, it's just these more general topics, and then we'll touch on this fun topic. I think it's really fun, of recursion in programming. Talk about that a little bit. I won't give anybody like a working problem to have to work through something using recursion. I remember when I first learned about it in college, and it was like it took me quite a while to wrap my brain around the concept. Like, my brain was not happy. So it would be a challenge to try and have you writing stuff, I think, immediately with it. Yeah, I guess we can get going. So yeah, we're going to start just, I want to give people some encouragement, right? Some advice from me, advice from other people on programming, especially for those of you who are just picking this up for the first time in this class, I've got some general tips and just talking about some of the frustration that you probably have had, and you've heard me say some of this stuff. And then I've got a whole bunch of quotes from a great article that somebody did where he just asked programmers, like, what advice would you give people when they're new to programming or trying to learn it? And I think a lot of it is just really useful and helps level set some stuff. I think maybe while I'm going through some of this, I might interleave some anecdotes myself just to help reassure people about, where you're at or how you feel, because it's a real challenge to learn to think the way that you need to think for programming. It's not something that for a lot of people comes naturally, and you shouldn't be thinking that it's going to be that way. Like, it's just going to be easy. I'm just going to pick this stuff up. It can take a long time to learn to structure your thinking effectively, because we're used to fuzzy thinking and fuzzy conversations and not the very, very structured nature that coding has. And it takes a while, just like, imagine all of these things that you've learned are like it's like you've got a new toolbox or something, and you're going to go work on your house and do some work, and you don't understand when to use what tool, right? Oh, do I use a hammer here? What do I do? So it takes a while to figure out like when to use the different tools and when they're effective. And that's just something that comes through practice. So first bits of tips I have is it'll start with just some of the challenges that you're encountering, right? Is when you're new to programming, it's really frustrating. It's more frustrating than it is when you get into it, not because necessarily stuff is harder. You're solving generally easier problems, but you're facing more than one problem, right? Maybe you don't even know where to start when you're trying to do something. Okay, I've got a problem. Where do I start with this at all? There's a lot of different things you can do, but I've definitely emphasized start by trying to think about the problem versus trying to write the code for the problem. Start by trying to think about how to break it down. And if that means you're putting comments there that are going to be placeholders for where code will go, take that approach. But if you start trying to write code first, you're probably going to be more frustrated than if you're just trying to think about breaking down the problem. You're going to feel lost. You're going to feel lost when you get started. You're going to feel lost in the middle of something, like, where am I? How is this code related to each other? What's going on here? You're going to get stuck, and you're going to get stuck whether that's just you're stuck on syntax and you don't know what's going on with it, or you're going to get stuck on a bit of logic and not know what you can do to try and solve a problem. Like, what tool can I leverage here? What do I know about that can help me solve this? And there's just so much, right? There's so much to learn, especially when you're having to deal with exact syntax. There's so much to remember. That's just really quite overwhelming. And probably, you know, if you're dealing with a lot of syntax issues, one of the big challenges you may have is you may be able to see what you want in your head. Like, okay, I understand, I can explain it, but I don't know how to take that and put it into the code that I need to actually solve this problem. So these are, I mean, in my mind, a good number of problems. Does anyone think that, like, anyone have something else that you would say, oh, this is the problem I've felt the most as you've been trying to tackle some of this? Yeah, I think that's all pretty accurate.
I guess for me too is we do things in class, and I'll go back to my notes and I'll work on a problem, and I'll look in class, and it's just a little bit different, just a little twist in it.
Yeah.
I'm like, I know this is the way we should be doing it, but there's just a little bit of change that.
Right, that was a good one. That was saying when we do stuff in class and then we go and have a homework problem, you know, it'll be just a little different. And so it's hard to figure out how to make that change, what to do for that little twist to get it working. And I think that's a fair statement. I could probably do some assignments that are pretty much a direct translation to get you in the habit, and then do more that are a little twist as well. But it's everything, when you get into coding, everything's going to have little twists and differences. And so it does end up being something that you have to get used to being able to work with. So, you know, in general, how do you work through these? The first answer here is not exactly I've got the trick. I've got the secret here on the first slide for how to figure out how to work through these. Yeah. Sorry. That's not, I don't have anything better than this. Literally, the best way to learn how to do this stuff is to just practice, you know, every single day, even if it's just thinking about it. If you can do a little bit of practice every day, even if it's I'm reading a little bit about this thing, or I'm writing the same bit of code that I've written the past week, but I'm doing it again and I'm understanding it, and maybe I'm doing it from memory today, whereas before I've had to use a cheat sheet to do it. There's not really a shortcut to just trying over and over and over. And I definitely want to encourage that every single day bit is important too. If you try and pick this up by doing it, say, once a week, it's like exercise, right? If I go running once a week, I may maybe maintain where I'm at in terms of my health, but I'm not going to get better. I'm not going to like be able to run faster or not walk as much, which is more my case versus running. You know, you need to do it often enough that you're actually building up that muscle and using it. So if you're trying to just set aside time once a week, it's going to be hard for you to really progress. You have to put in effort. Maybe not every day, but most days you have to put in some effort, a little bit of effort. And so just set aside some time. It doesn't have to be a huge amount of time for you to get better, right? It could be 5 to 10 minutes, 20 minutes, 30 minutes, whatever you can find as a window. You've heard me emphasize this a lot, is when you're working on a problem, break them down and solve the smallest part first. And when I say smallest part, and I've tried to do that in class, I mean the smallest part of a problem, right? Think to yourself, like, what is the very first step that I need to do here? And I could send you, this is not just my advice. This also isn't just advice for learning how to code. There's a whole, we'll probably touch on it. I don't know if I'm going to use it as the basis for our future stuff, but there's a whole branch of, or a whole way of doing development called test-driven development. And the idea is that if you guys haven't noticed, when on these REPL.IT problems, when you submit it, it runs some tests and tells you whether you passed or failed. That's other code that I wrote to test the results of the code that you're writing. That's a whole branch of, or a whole way of doing development, where the idea is before you write any code, you write a test that's going to fail because your code doesn't do what you want it to do, and then you write the code to make your test pass. And that way you are both in the tests stating what your expectation is. Oh, I expect the code to do this. And then you also have something to make sure that if you change something, your test will break if it's not doing what you expect. And one of the interesting things about that is the people who are the biggest proponents of test-driven development will do the tiniest change they possibly can, and they'll write tiny tests. Like the very first test, if say they're trying to implement a new method or function, will just be that the function exists. Like, oh, I've got a function and I can call it. And that's might be all that they have. And then their very next test, if we were to, I don't know, let me choose an example, right? We're doing some sort of word processor and we've got a get font size function. Their next test might just be that it returns an integer, and their code might just return 12 instead of even having any other logic. And then they'll just build it up tiny, tiny piece at a time. And that feels like you're not doing much, but by doing that, you'll actually end up moving faster in the long run than if you try and do all of the code at one time. Another really important tool is to research and review what you already know. A lot of times you can solve the problems that you're encountering with the tools that you already have. There's patterns that you're going to see. There's things that jump out at you. So been trying to figure out how to create a good cheat sheet for this that can go together. But there's things that if you're looking at a problem and you hear terms or you read terms or things, some of your tools should jump out as a way to solve it, right? And that goes back, let's go to that tool shed analogy we had, or toolbox, right? If you've got a project, that you're trying to build and it says, put these two boards together, I'm looking at my toolbox and I'm going, all right, I'm probably going to use a nail and my hammer, or maybe I'm going to use a screw, but I've got these tools, right? And so in coding, if you've got a problem and it says, get every odd number out of a list, you can already go, wait a minute. That sounds like I'm stepping through something, every out of something. I'm probably doing some sort of iteration. So I'll go into my toolbox of for loop or while loop or some way to step over all of the items in this. And sort of reviewing what you already have as your tools is very useful because it'll help you remember, oh yeah, I've got that tool ready that I can pull out and use. I really encourage you to experiment and test with your code. Try stuff out, especially both you're not sure how it works at all, try things out, but also after maybe you've gotten something working the way you want, make some guesses. And when you're doing this, even if you do this with literally a handwritten journal, it could be useful to do it sort of with this approach. Go, okay, I assume that if I make this change in my code, it's going to do this now as a result, and then make that change in your code and test it and see if it does that. Because when you're learning how to program, what you think about how the code works and how the code actually works might be miles apart to start with. You're thinking it's going to do this and it actually does this. But over time, if you make an assumption about what it's going to do and then you watch what it does, it'll shift in two different ways. A, your assumptions will get better because you'll go, oh man, it wasn't doing that. Maybe I had the wrong assumption about how it works. And B, it sounds almost weird. The code doesn't change how it works, but not only will your assumptions get better, but it will line up together with how the code actually functions underneath as opposed to just getting lucky with them. And then you'll be able to really make assumptions about how code will work without even executing it. You'll be able to think about, oh yeah, I know what the code is doing underneath, and so I can apply that. And the best way to do that is to experiment. The more that you try things, the more that'll start to click, and you'll go, oh, that was like, I thought this is what was going to happen, but really this totally opposite thing happened. Why would that be the case? And when it is different, stop and ask yourself, why would that be different than what I thought was going to happen? What could cause that? It's almost a scientific method type approach. And never forget to take a break. Just don't beat your head against a wall for hours. There is a whole field when it comes to dealing with especially complex programming problems. There's talks and everything on it, and it's one of my favorite concepts. Depending on what you want to call it, my favorite name for it is hammock-driven development. Literally, the idea is what you do is you look at a problem for quite a while, and you try and think about all the different aspects of what you're trying to solve, all of the things that are involved, and then you go and relax. Walk away. No joke, walk away and let your subconscious work on this for a while. And so when it comes to, I can tell you, this is probably the most effective way I solve major problems that I'm encountering at work or when I was in school. I would just be staring at something. I'd be like, all right, I cannot figure out how to solve this. And I would go to sleep, and at least a half dozen times, literally in the middle of the night, I'd just wake up and I'd be like, oh, of course that's how I'm going to solve that. Oh my gosh, I don't know why I didn't see it before. And so there really is something about, the key part there is you can't walk away without trying to think through this stuff, because you need to sort of load your brain up with what is going on there, and then let your brain start working on what's actually happening in the background, and it'll keep processing on it. Yeah? Yeah, it's very true. That happens. You'll solve it the next day, and it's not that the time was necessarily a waste. It's that you were looking at it, but we could get down into some, a deep brain, how your brain works. But essentially, there's what's known as like two modes in your brain, and there's a whole bunch of different ways that they're termed. You could call them L mode and R mode, or different stuff. But one of the modes is like a focused mode. It's you're driving what you're thinking about. You're very specific, and that's the mode that you're using a lot of times when you're directly trying to accomplish a task, right? It's like, okay, I am, driving this car to a new place, and this is this very driven mode. And then you've got, I can't remember which one maps to which. I think that might be like R mode, and L mode is the more loose, right? That's like the creative mode. And that's where your brain is making these different connections between things. It's taking these different disparate concepts and putting them together. And your brain just does not very effectively operate in both ways at the same time. So if you've ever been in, say, like brainstorming sessions, or you've ever heard people talk about it, they'll say things like, the first part of this brainstorming session, we're not shooting down any ideas. Our job is not to criticize ideas, it's just to come up with anything. It doesn't matter how off the wall, it doesn't matter how strange. And the reason is because that point is where you're trying to be creative. You're trying to do something unique. And when you start thinking about, well, how does this work? How do we apply, is this practical? You're already in the other mode of thinking, and you're not going to be able to come up with interesting new ideas as well, because you've shifted over to this, how do I break this stuff down? And programming does involve both parts of that. Yes? I've heard them as L mode and R mode. There's other terms for them as well. Oh, hammock-driven development. There's a great talk on it. Yeah, if you Google hammock-driven development, there's a great YouTube video from a developer talking about it. And there's other terms for that, but that's just my personal favorite, because I keep trying to convince my boss to let us put a hammock in the office. Like, I just need a hammock. I'm telling you, I'm going to be more effective. Haven't succeeded yet, but I'm trying. All right, so that's some of my advice. Now, let's take a look, and this is a link. When I post these slides, after class, or these notes, you guys can click through to this if you want. I think I may even have it up here. I've got it over here. So this is just somebody asked for advice from other programmers. He sent a question saying he's going to be speaking to impressionable youth in a couple of days. They're in their early years of learning. What is your one solid bit of advice? And so I stole some of the ones that I like the most out of what he had there, out of hundreds of responses, and put them on here. And these are, I think, all really important things to remember when you're learning to program. And the first bit is really programming is not just, it's not a technical endeavor, it's a group thing, right? People are involved. And so you need to be supportive and kind. You need to help build up other people. I hate the idea that some places push like rock star developers or anything like that. I've been in places where I've worked with just toxic developers who thought they were really good, and they might be able to write code effectively, but they destroy a team because they're not working with other people. And it really is, I mean, in the end, we're just trying to accomplish something, right? The point is not to be the best programmer in the world. You want to have an impact, and you want to help other people. And you're not going to do that if you're not trying to build up and being supportive of each other. Yes.
How much team-based is actual industries?
How much team-based is the industry? It varies a lot from company to company. Some places it is sort of solo work. It also depends on what level of work you're doing. So if you're doing, I would say, very deep, very specific work on something, maybe this probably doesn't apply to people right here, but maybe you're doing academic research or that level of work, like, oh, I'm looking at artificially, self-driving cars or deep AI logic. You're probably going to spend large chunks of time on your own doing some real dedicated work on that. In the day-to-day, in a lot of companies, you're frequently working directly with other people. Like my team, we're talking with each other all the time. When we're working on a problem, it's almost never that somebody just takes their work item and goes in and works on it and comes back 3 days later and delivers it. In fact, the process we have is we're usually saying, oh, well, how should we do this? Like, what's the design? Does this make sense? Let me go back and ask my coworkers, what do you think of this design? Do you like that design, or is it going to fit our existing stuff, or are we going to have problems with it, right? And that's because someone else is thinking about a different aspect of it. They're going, oh, no, that's going to have a problem with the database. We need to change how that does it, how you solve that, because we're going to have issues in the database. And then on a lot of teams like mine, you have code reviews. So you're not just pushing your code out. Before your code can ever go into the actual product, other people are taking a look at it and giving you feedback. And then some teams are even more collaborative than that. There's concepts known as like pair programming, where literally you sit together at one computer and work, and one person is like typing and doing the coding, and the other person is trying to think about the problem space. And some teams have even taken that farther to the concept of mob programming, where there's literally the whole team is at one computer all day, and they're just sort of rotating who's doing the coding, and the other people are there giving input or advice or working on it. So it can vary a ton based on the team that you're on, but there will be, collaboration and working together just about anywhere. It's a good question. Any other questions about that? Like collaboration? And it really does matter, because it plays a huge role in how you're doing. I can say I haven't always had the best interactions myself, because I can be, blunt or loud or have obnoxious opinions. And I've had to learn how to balance that with working on a team effectively, right? Like, oh, this person has a different opinion and we're not wrong, and they're going to have a harder time expressing that opinion because I'm such a loud personality. I need to learn how to step back a little bit and let them talk about their opinion and advocate for it before I do mine, because otherwise they're going to be intimidated. They're going to be scared, right? You need people skills. Yeah, honestly, I think people skills are, once you reach a certain level of technical skills, which I would say everyone here is capable of reaching, but once you reach a certain level of technical skills, then for the most part, the most important thing in my mind to continue advancing is people skills, not the technical skills. Sure, if you're trying to be, again, like the rock star person, the 10 times developer, that's a different scenario, but that the vast majority of people are not even wanting to do that, and it's not necessarily the best environment anyways. Oh, look, here's the same advice I gave you. There are no shortcuts. Practice, practice, and more practice. Sorry. This is really good advice too. If you're just one page ahead in the manual, you can mentor someone and help them along in their journey learning to code. Don't forget this. Don't forget that probably, in fact, I would argue you'll be more effective. You'll learn more effectively if you're doing that, because that's probably the best way for you to learn, is to help somebody else with a concept that you're just getting a handle on, and you're going, oh yeah, I think I've got this one down. Let me help you work through that problem. And the other person will probably benefit a lot more than picking it up from somebody who's very, very well versed in it. Sure, you get different perspectives, but they're going to have somebody else there who they feel at least is in that same struggle and has been struggling with that. Whereas if somebody really well versed in it, they may think like, oh, I don't know why I don't get this, and they do. It can be intimidating. You're going to keep learning. There's really no end when you're in this field. There's no, okay, I've learned how to program. I've learned everything I need to know. You're just going to have to keep working at it. You're not done. It takes practice. Find sources to read. Books, blogs, different sources. And yeah, this one's almost discouraging, but it's true. Like, don't expect to be great in just 6 months. Like, you're not going to be an amazing programmer in 6 months. You may be able to say, okay, I feel like maybe I'm beginning to get a handle on how this stuff works 6 months after you've learned it, but you're not going to just have everything down. I think this one is really, really important. Don't compare yourself to others. Compare yourself to where you were in the past, right? Think about, don't say, these other people totally understand this concept and I don't get it. Oh my gosh, I'm not going to be good at this. It's not going to help you out. You need to say, wait a minute, yesterday or 2 weeks ago, did I understand this at all? And now do I understand it a little better, and am I making progress, right? All that matters in that sense is you're getting forward progress towards it yourself. And if you're comparing yourself to where other people are, you're gonna have a challenge. This class is a good example. We've got people in here who have never touched any programming before. They've never done anything in that. And we've got other people who have written in several different languages, right? If you're comparing yourself to someone who already has experience in other programming languages, you're going to be hurting if you think that you should be at the same point with what you've learned. You're gonna feel overwhelmed. I don't know if I have one on here that mentions it. Oh yeah, I think this is it exactly. Like, never be afraid to say that you don't know something. Don't be afraid to ask for help. We all suffer. I think we can get rid of the ED on this. We all suffer from imposter syndrome. This is true. Like, I've been programming for a very long time now, and so often I suffer from imposter syndrome. Just like, I don't know what I'm doing. Oh my gosh, this is way beyond me. I'll never get it. And it can be the silliest things. Here's one that I've been thinking about this past week, just because I was using a different library, and it's very silly. But most of the functions we've written, right? They've got a word as the start of them. And there's a habit among some people when they write functions that are supposed to be like very low level or doing something in the code, that maybe the function starts with underscores as opposed to a word. I realized this week, just clicking on it, every time I encounter something like that, I immediately pause and I'm like, oh, I can't understand how this works. This is too complicated. Oh my gosh, there's underscores in this function name. I'm scared. Like, I don't know what to do. Why? It's just, all they did was name it a little different. There's nothing magic about that, but I get intimidated by that. I'm like, this is going to be too much for me. I need I can't figure out how to make that work. It's not been true, but it's definitely something it's just one of those silly things, right? Like, I need to tweet out, like, please stop putting underscores in your function names. They're intimidating. They scare me. So, I mean, you're all going to suffer from this. You're all going to be like, I really don't understand any of this at some point. And being open about that, talking about it, learning how to work through that is critical. We all make mistakes. Try to honestly accept responsibility for your mistakes without being ashamed, and don't put shame on others when they make mistakes. right? Especially when you're learning, don't think, oh, I don't know why they don't get this concept. This is so easy. We all get stuck on different things. Different stuff causes us challenges. Maybe we missed, we didn't quite catch the description of something, and so it didn't click for us. And if you aren't just willing to accept that, and you want to pressure other people that, oh, why don't you see it? That's going to be a challenge. You're also going to make mistakes in coding, and eventually you're going to make some mistakes that are going to go into production, and you're going to feel, if you keep at it, like, oh no, I put that out in the world. How did that happen? I'm in so much trouble. You can't beat yourself up over it for the most part. You try and do your best. You try not to have that happen, but it'll happen. It's pretty much everyone. I know on my internship, I was working on, my stuff, working on my project, and then suddenly the database was gone. And I'm looking at my code and I'm like, oh no, I deleted the database. Like I figured out, like I meant to delete like a row and I deleted the whole database. And I was freaking out over this. I'm like, oh my gosh, I'm dead. Oh my gosh. And I went to my manager and he literally laughed at me. And he's like, you're not working on any production database. Just go tell them to restore the development database. Like, they're not going to have you work on anything real. It's going to take them 5 minutes. You're good. I was like, oh, okay. It was a lot better that I went and talked to him about it right then. So I was able to get back to work versus, being intimidated by it and not. Going back to talking about, relationships, like, tech is ephemeral. It's going to come and go, but relationships last. Get to know everyone in this class. Like, make sure you guys are chatting with each other. Make sure you're talking, getting to know each other, learning how to support each other. Talk about where you're struggling. Talk about the things that you don't know about. I mean, really, please, if you have an area, a topic, something that we've covered in class that you're saying, this just hasn't clicked for me, I don't understand this, or I really maybe completely missed it, post about it in Slack. Do it right now. Do it later. I don't care, but say something. Say something, because that's the best way for you to move forward is to just ask about it. I've learned this as well, because you'll get into industry and you'll be in your business and people will just be saying words. You'll go into a meeting and everyone's like, oh yeah, we've got the PRT, and once we resolve that, then and I've definitely learned to just throw my hand and be like, what does PRT mean again? Because I don't know what you're talking about, and I want to make sure that I'm following, because I'm completely lost right now. And sometimes it's funny because somebody may even be like, oh yeah, I didn't know what they were saying either. I was just going along. I had no idea. Oh, of course that's what's happening. So ask questions. Just be willing to talk about where you're at and ask questions, because that's much better than being intimidated. In fact, for anybody, again, if you're watching this or if you've fallen behind, like some people I've talked with them and they're like, oh, I just feel so behind in this class. I can't get caught up. I can't keep up with the homework, or I wasn't able to do the homework or anything like that. Don't feel intimidated. Don't feel like you need to, this is too much for me, I need to walk away. Like, if you don't talk about it, we can't help you figure out how to work through that. And that's really what we're here for, right? This is not a college class to weed people out. This is an opportunity for you to pick stuff up and learn it. Even though this will be the last class for this, we'll have a couple-week break. During that, I'm going to talk with Daisy, see if I can get a dedicated space where I'll come in. Hopefully I can get it where I can come in and work on the material for the next class. But at that same time, if other people want to come in during that time frame and work through, I didn't understand this concept, let's talk about it, we should hopefully be able to do that. I just need to figure out if we can get a space set up for that for a couple weeks. And this is stuff that I've emphasized a lot. Languages and tools come and go. I'm teaching JavaScript in this because it's by far the most common one in the industry right now, but they come and go. The more important thing is to learn to see patterns, or rather rhyme in different languages and libraries and even paradigms. Learn to see these patterns. And when you can see that and you can learn and you can put these things in sort of a tool set, then it'll be a lot easier for you to be able to apply them with a different language. And this one, the last bit of this is probably just a hair beyond what you guys are doing, but learn to ask these questions. Like, how do I know it's working? That's a critical one. How do I know it's working? And how do I automate that, I think, is really good. The how do I automate that is how do I automate knowing that it's working? That's, again, a little bit beyond, but that's getting into how I was able to do the REPL IT exercises for you guys, which is I automated the tests for those. I wrote tests so that every time somebody submitted something, I didn't have to sit down and check and see if the code was correct. The test ran, and it could tell you whether or not the code was doing what was expected. And this is just a funny one we've had on here for a long time, but you know, when you're programming, you're sort of going to alternate between these sort of states a lot of times. Like, you're going to do something, you'll be like, I've solved the problem, it's amazing, oh my gosh, it's all good. And then other times, you're just going to be like, I don't know what I'm doing. I'm completely lost. I'm just pounding away at the keyboard. Maybe something will work. Like, this is going to happen to you. It happens. It's just continual. It goes back to that dip I showed in the very first class. Every time you're picking up something new, right, you're gonna be like, oh my gosh, I figured it all out, and then you're gonna crash and be like, oh, this thing's way more complicated than I thought. And then you're gonna have to work your way back up and work through it bit by bit. So that was just general advice. Any other thoughts or questions on just high level advice?
I feel like it might be failing my head, so I'm going to just like listen and see if there's anything I can catch on, you know, that I can relate to a little bit, just do well.
Yeah, I think I sort of caught some of what was being said at one of those, but I haven't really attended one. The question was about this Google event that's going on. I don't think, usually at those, it's much less technical. They're not going to be talking about a specific technical topic. They're going to be more talking about what it's like to work in the industry, what it's like maybe to work at Google, what they're looking for. Google is a unique challenge. I don't know if they've changed the way that they do their interviews from the way that they used to, but traditionally they've had interviews that I feel dramatically over-biased towards traditional computer science education. So a lot of their interview questions have traditionally been these very almost academic type questions where they'll ask you to do things that you're probably never going to do in most day-to-day programming jobs. So they've got a little bit of a unique aspect there, and a lot of tech companies will do that. They'll ask, but not all of them. And I think that they're starting to see also that unfortunately creates filters for just a very small subset of domain knowledge and just gets you back the same people over and over. And so I think they're trying to broaden that out and do interviews or stuff in different ways. I think this is part of that, is trying to create this pipeline for other people or people who maybe didn't come from that exact same path. And so, yeah, the deal there is it's definitely, in my mind, it's like jumping in and saying like, oh, I'm ready to interview at Google, you know, unless you've got a lot of other experience with other programming languages and this was just you picking up some JavaScript syntax, you're not going to be there yet. But the key advice for attending an event like that is to be saying like, what can I pick up about what they're saying? Like, are they saying they're looking for certain things? Are they saying that these are the characteristics that they're looking for of the people that they want to hire, and jot that stuff down, and it might be able to go into a learning path that you create, right? Like, oh, they're really looking for people who are strong in this stuff. Okay, maybe I can put that into some sort of learning path to make sure that I'm building up those skills. Other questions right now? All right, so let's talk about some other resources. And I've got one that I didn't put on here, but hopefully everybody saw it. I posted another set of exercises that people can work through on Slack the other day. I can post it again if you want. It's a fork of an existing classroom on REPL IT. So I didn't write the tests for any of these things. I didn't write the exercises, but by forking it so that you're doing it through the classroom that I have, you will be able to like submit for help or ask for help from me, because it'll go to me in there. And that's a lot more exercises. There's like 165, I think, in there. Once you've worked through everything in the exercises that I have for this class, and sort of over the next couple weeks while there's this gap, that's what I would really encourage you to use as sort of a primary tool, because it's something that we're all, people can join collectively and everyone can dive into that and work through them. And feel free to ask questions. Again, like, hey, I'm stuck on this one. Heck, maybe I'll work through them too. Maybe I'll just join. I don't know if I can join the class that I'm a teacher in. We'll see. I don't know how that works, but maybe I'll try and work through all of them as well, just to see how it goes. But it's a lot of repetition. And that's really what you'll need to do when you're picking this stuff up, is that sort of repetition. Like, if you did work through any of them, you'll notice that the first 4 or 5 are almost the same problem. And the great thing about that is, all right, now I've done this. The next one should be a little easier. The next one should be a little easier. And then it starts building. But use tools like that. And those ones are good because, again, they've got automated tests. They're very small. They're very focused. But if you want some learning resources or reading resources, here are some great ones. Again, I'll post these. I've referenced this before, and I think it's even in the resources link on the GitHub profile. There's a book called The JavaScript Way. It's a nice introduction. Part 1 really covers a lot of the same stuff that we did in class here, except it might use a little bit different syntax for some of things, because I think it uses the newer JavaScript syntax. But part 2 and 3, those are things, if you want to build and move forward, they build on the knowledge of JavaScript and add in knowledge about web development and HTML and CSS to build a web server and a website. And this is that would be a great thing for you to work on if you're looking to work ahead. You want to pick up stuff for the intermediate class, because what we'll be talking about in the next class will be more like a buffet of different topics, but some of the ones that we'll talk a fair bit more on than others will be like HTML and CSS, and how do we use those programming languages and JavaScript to build a web page. So that would be a great resource to dive into those further steps. And it might move a little faster than we would in class. Another resource, if you haven't been to it, Free Code Camp is a great website. They have a whole bunch of, again, exercises that you can work through with instruction. So if you feel like, well, I need more description versus just exercises to practice, this might be a really good one to go through. They also have a blog that just posts tons and tons of stuff, probably too much, honestly, nowadays. A lot of people will follow it. I think they're very excited. I think their blog just broke into like the top 2,000 websites on the internet. So it's a very, very busy site now. But that's a really useful site to get another stab at hands-on exercises and another description of how to work through things. I like One JavaScript. This is a great tutorial on programming in general and JavaScript. It definitely moves at a faster pace. It's not the same pace as we did in class. By the time you get to chapter 3 or 4, which is teaching objects, you're already going to be flying past what we've covered in class, and that's about a third of the book. But it does try and teach things from this well-structured, good pedagogical base. So it's trying to use a good base for you to learn the language from. This one, if you just really, really want to learn the ins and outs of JavaScript down to the core of how it works, there's a whole book series called You Don't Know JS. It's by a guy named Kyle Simpson, and they're all available for free online, but you can also buy them if you want. Amazing books. By the time you get past book probably 1, maybe 2, like they're going to be way deeper than this class, and some of it is deeper than anything that I dive into. This is the type of stuff that I may look at when I'm like, oh, I just want to go read about computer science stuff at a deep level. But a great resource if you're really into that. And then if what you want to do instead is you're much more interested in, I talked about how to think versus just learning a language. This is sort of a classic book, and I've provided a link in here to an online interactive version versus just a static book. It's called How to Think Like a Computer Scientist. Now, again, if you're trying to pick up JavaScript, you really want to get good at just JavaScript, this is probably not the book that you want to leverage. But if your job is to, if you want to learn how to think like a programmer, you want to learn like what these patterns of thought are, this book is a fantastic way to do that. A lot of people have really found this to be one of the best tools to help teach them the way to think about coding and think about programming. Any questions about those resources that I posted? Yeah? There's a lot of different stuff out there. The challenge is, you know, I mean, there's way too much for me to try and figure out what is and isn't useful. What I would say is you know, this is another one of those find peers, find other people. So what might work really effectively is, you know, whether you want to choose one of these resources or something else, post about it maybe on the Slack, whether it's this Slack, the general Slack, or the one for this class, and say, hey, I'm going to start working through this. Does anybody want to work through this with me? Because if you get somebody else working through something with you, it will probably help you out a lot more than trying to just go grab resources all over the place and work through them, right? It'll help keep you focused on it. It'll help keep you motivated to work on it. But if you find another resource and you really think like, oh man, I want to watch this video course, I want to do this, it can work. I think finding something that involves hands-on exercises is going to be critical at this point where you're at, because you need to work through stuff yourself. You'll be able to watch a video a lot of times and say, oh, I totally understand that, and then not be able to put it into code yourself. So the more you can do those hands-on exercises with whatever resource you choose, I think the more effective it'll be in helping you out in the long run. Other questions on other resources? Or others that people really want to highlight that they're aware of? All right. So let's do a quick, just this isn't long. This is just sort of talking about what are we going to touch on when we move on to doing some of this intermediate stuff. And this is sort of a bridge, if you will. So it's a bridge between the basics of programming and being able to work on something larger scale. So it's going to touch on some topics that will all be critical to that. That includes being able to work with version control, which we haven't talked about in this class, but this is really important to working on anything outside of just small one-off exercises. If you want a quick description, version control is, who here's ever written a paper for class or something? Anyone? Yeah, most people. Who saved like version 1 and then they saved like revision 2 and then revision 4 files? Renamed it every time? Yeah? Yeah? No? You just save it over the same file every time and lose your changes? You know? Wow. Bold move. Version control is basically a way to do that without having to save a whole bunch of different file names. You get to save everything with the same file name, but you have your whole history of what it was at every point in time. We're going to talk about HTML and CSS. I'm going to give an introduction to those. We won't be able to, those are huge topics themselves. Like if you were to, CSS to me, the real wizards of CSS, those people can do amazing things in tiny bits of CSS that just blow my mind and I'm stunned at. And I'm like, yeah, I can maybe lay some stuff out, but I am not a CSS magician, so I'm not going to be able to give you all of the crazy, super cool CSS stuff. If that's what you end up really liking, though, you can make a whole career out of just doing design and style and markup. If you're like, oh man, I really love doing this UI bit and making stuff look cool, you can end up building just off of that portion and turn that into a career. We're going to talk about web servers. A lot of people don't really understand how the web works, so we're going to do sort of an overview of just how the web works. We found that in the Rails class early on is we'd teach people Rails, and then they didn't understand where their code was running. And so we definitely learned we needed to give more of an introduction about how all of this stuff works. And then we're going to talk about new JavaScript syntax. So none of this will be particularly new concepts. This is just going to be new ways to do the same things, because a lot of newer tutorials, newer frameworks use this newer syntax. So that shouldn't be too challenging as long as you're comfortable with the concepts and you don't get hung up on just the syntax that we're using. We'll talk about how to work with stuff in a larger ecosystem. You've heard me talk a lot about being lazy, and functions let me be lazy by writing something once. Well, NPM modules let me be even lazier by using somebody else's code. Oh, somebody else already solved this problem? I'll just pull that in and use their code. I don't have to write it again. And as I said, like, a good way to prepare if you want to start getting ready is to start reading parts 2 and 3 of the JavaScript way, because that's teaching you a fair bit about servers, teaching you about HTML and CSS a little bit, etc. Any questions on that? All right, the only new coding concept for today, and then we'll be done with that, and I can help some people with hands-on stuff. Let's talk about recursion. Is anyone familiar with recursion? Let's talk about recursion. Let's talk about recursion. Let's talk about recursion. All right. So what is recursion? Anyone got a definition? Anyone know it? What? You're going to Google it right now? Oh, man. Look, my slide is done wrong. Recursion is a repeated application of a recursive function. Wait a minute. You can't define something in terms of itself. You're cheating. Yes, I am. But that's what recursion is. Repeated application of a recursive function. So we'll have some fun with this. It's a very fascinating concept in computer science. It's a very cool way to write things. I don't have anything on that slide. Where did my slides go? Maybe I've got my slides in this format, or maybe I didn't refresh my thing. All right. There we go. I just didn't refresh my window. Or another way to think of it is a function that calls itself. We've called functions from other functions now, right? You don't always have to call them from the base of your application, but a function can also call itself. There's nothing that prevents that from happening. You just use that function name inside of your function to call itself again. So the question is, why would you want to do that? Like, that's weird. Why am I calling a function from itself? Well, what's interesting here is we can show mathematically that anything that can be done with a loop, so any of our computations that we've done using loops or iteration, you could also do that same thing with recursion. And sometimes it's just easier to reason about a problem recursively versus iteratively. Sometimes it's easier to think about how to solve something in a recursive fashion than it is in an iterative fashion. So let's show, I mean, we'll do a bit of hands-on in just a second, but let's create a recursive function here. Make this a little larger. And this is going to be very, very simple. And it'll have something that just seems obviously like we're going to have a problem. So let's make one. Function. What am I going to do inside of my recursive function here? You know, I hate to do this. Hate to do a console log after I've been emphasizing, don't log stuff inside of your functions. But I'm going to do it just for the sake of making it easy to see something come out of this. So right now what I've done is I've already created my function, and you'll notice inside of my function I'm calling it itself again. So I'm calling say hello again in my function. But if I ran this code, anybody have a guess as to what's going to happen? What? It doesn't print it out ever. What? It doesn't do anything actually. Oh, I didn't call the function in the first place. Okay, now I call it. What do you think is going to happen? It's going to print out twice? All right. I heard run forever as well. Any other guesses? They ran, well, it would have run forever, but eventually it blew up. It told me maximum call stack size exceeded. So I blew some stuff up. And that's because if we think about what's happening in the code here, and we could put this over into, say, the Python tutor, the JavaScript tutor thing, but if we think about what's happening, we call say hello, we go up into our function, we print out hello, and then we call say hello again. But we haven't actually, at that point, we haven't yet exited our function, right? We've gone in, we've called it again, and we're running it again. And because the call to say hello hasn't finished yet, we just keep adding more calls into our function stack. Yes?
And I got a little bit. Why do you have console log inside a function?
Yeah, I know. That's exactly what I'm saying. I shouldn't do that. I shouldn't be doing that. I shouldn't be doing that. I should not be doing that. You are correct. This is bad code. This is bad code. Don't console log in your function like this. That's not the way to get a value out of a function. But I was cheating because I'm never returning from this function. And so I didn't have another way to get a value out other than cheat it out. So you're completely correct.
I just want to say why that code, right? Doing the same thing.
Console log
Oh, no, we already talked about that.
versus returning.
Yeah. We talked about
It doesn't really do the same thing. Here, let me show you. That's where I think I'm going to take a moment and sidetrack on that for a second because it's something that's come up a lot. So let me show you the difference real fast. Running some code. I'm going to get rid of this and we're going to do the difference between console log and say hello. Maybe it'll click. I'm not sure. So let's return hello from this function. And let's run this code. What did we get printed out? What? If I run it, what do I get printed out? Nothing, right? Nothing. And the key part here is that's what I wanted. But this function is doing exactly what I want this function to do. This function is returning a value. And the difference is I'm just not printing that value using a console log here, right? Now, I think what happens, especially when you're learning code, and you guys have encountered this a lot, is the way you guys are used to seeing what's happening in your code is console logging it. But that's not actually what's happening in your code. That's just giving you some visibility to what's happening in your code. And so then it can be easy to mistake the fact that you see what's happening in your code with your code doing the right thing, because I see the same thing two different ways, but it doesn't mean that it's necessarily doing the right thing. So here, let's compose this. I'll create another function, because we were saying functions can call functions. Say Jared, say hello. Or let me do it this way. Add name to hello. Right? And this thing, what it's going to do is take in existing string of some kind, and what it's going to return is, I'll do it using string concatenation, it doesn't really matter. I'll say hello plus my name is Jared. And so right now, let me do a few things here. If I say hello, again, it printed out nothing. But it's still calling the function correctly. And so we can test that. That's where this gets misleading, because you're like, well, how do I see what it did? Oh, the console log is the way you see what came out, but it's not actually giving you your value. So I'm going to store this in a variable, though. Bar greeting equals, I'm going to get say hello, and then what I want to log is my greeting here. I need to rename this file because this isn't going to be my recursive file anymore. Let me, yes. Just So I don't need this. Before I've called the other one, if we look at this now, I have a bug. Does it not have my, oh, it tried to call recursive, right? Called the wrong function. So if I call this, I just see hello, right? And that's why because it's what you're seeing when you console log, it could be easy to think that console logging inside of your function is doing the same thing as returning a value from your function. But here's where an example, I hope, that shows why it's very different and why one isn't the same as the other. If now I'm going to change, or now I'm going to write this, and I'm going to add to my greeting. I'm going to change my greeting to say add name. I'm going to pass in the existing greeting. Then I'm going to console log that. So I'm just putting it back in the same variable I had before. What I'm going to get here is we get hello first, and then hello, my name is Jared. Because I had this string that I returned from this function, stored it in this variable, I logged it, and then I passed that into add my name to hello and returned those two things put together. Does that make sense for the most part? People follow that bit? So here's why, this is why I'm emphasizing that the console log is different than, console logging in a function is different than returning a value. Let's change this code now. I'm going to comment this out, so I leave this stuff here, and let's console log hello. You're going to think, okay, well, that's sort of the same thing, except now it doesn't work. And the reason is because it didn't send out in a way that anything else can use a value that's readable. It printed it to your screen, but the only way other bits of code can leverage what comes out of that function is from the return value. So logging it looks like if all you're ever doing is maybe one function call, if all you're ever doing is the output of one thing, it can look like a console log does the same thing as returning a value, but it doesn't, because the rest of your code can't work with it the same way. It's an unusable thing. It's sort of cheating your code, and the rest of the code can't see what's going on and work with it. Does that make sense as to why there's a difference between the two?
No, I see it. I see it. I mean, I can see it. I can describe it on Thursday.
Yeah. For people who didn't hear me describing it on Thursday, I like the analogy. It was fun. So I'll talk about it on video. You know, imagine you're like, this is like a movie. Okay, so you're in a movie and you're staking out some building, and you keep, it's like a tiny little building, right? And you keep seeing people go into the building, and you know that they've got to come out at some point, but nobody's coming out of the exit. You're like watching the exit, and people keep going in, and nobody's coming out of the building. And you're like, what is going on? There are like 1,000 people that have gone in, and there's not room for 1,000 people in there. And I'm watching the only exit, and they're not coming out. How can that be? And that's a little bit like what happens if you write a function and you're using console log to get something out. It's like you've got a secret exit out of your building. Like, oh, they went down through the underground tunnel and snuck out this other way. And anything trying to watch can't see what's happening. It's sitting there watching and going, all right, give me back a value. It's nothing. Dang it, give me back a value. What is going on? Why am I getting nothing out of this, right? So console log is like, it's a little bit, and you're sort of cheating your black box. Your black box, the only exit out of it isn't where something's coming out. You know, drilled another hole in the bottom and throwing stuff out there, and it's sort of it's a very dangerous habit to get into of using it to see stuff like that. Really, in my mind, the only good use for doing something like a log inside of a function is to help debug your code and see what's going on at that point in time. You don't want to do it as your way to get values out ever, because it will not work the way that you think it will. I don't know if that helped anybody, provided any clarification, but that's got to be one of the most common things that people do. And so there's obviously got to be a better way to present that material so that it sort of makes sense. But yes, I was cheating. I want to use a secret hidden door to get values out of this. That's exactly what I'm doing. And the reason is because I keep putting rooms inside of rooms inside of rooms inside of rooms. And the only way for anything to ever get out is to jump out the back door, because nothing can ever make it out of all of the layers of the rooms that are there. So in my recursive version of this, I was definitely cheating. Does it make sense that a function can call itself? It's sort of weird what's happening there, right? A little bit strange. This may not even let me do it. Let's see if I can put that same code over here. It might completely fail, because it might be smart enough to know that this stack will blow up. We'll find out. This might give you a good visualization if it does work. All right. I don't think it's going to let me do it, because it has to execute the code to create its visualization, and it's not going to be able to execute the code. I'll have to show you with an actual working example as opposed to this. So we'll do that in a minute, but let's do this collectively. We're going to do this as a group to sort of practice it. So we're going to compute the sum of the numbers from 1 to n being whatever number we want it to be. And we could do this pretty easily with a for loop, if you will, but we're going to do it recursively instead. And I'm going to give you the algorithm for how to do it recursively. And then instead of us writing it in code at first, we're going to collectively do this. Every one of us, and I'll start it, and I'll go to the next person and on down, will do this algorithm and give back what you think the value should be based off what you were given. So the algorithm is the sum of n. Oh, I've got a typo here. No, I don't. I think that's right. So the sum of n equals 1 if n is 1, or the sum of, sum of 1 to n. Otherwise, it's the sum of n is equal to n plus the sum of n minus 1. So that's the algorithm. Any questions about that algorithm? So here's what I'm going to do. Let's start. And I'm going to start with 5 here. All right? We'll do 5. So I want to compute the sum of all the numbers from 1 to 5. So the way I do that is I'll say, okay, 5 isn't 1. So 5 plus, and I'm going to have you do the sum of 4. So I'm holding on to 5, and 4 isn't 1. 4 plus
3.
4 plus the sum of 3, right? But you need to ask the next person to compute the sum of 3. We're going to create a chain here.
Okay, so
Well, we're going to use this algorithm. So is 3 1?
no.
Okay, so then you'll hold on to 3, and you need to ask him to give you the sum of 2. All right? Okay, so you give him back 1, because so now because we're just sort of stacking this stuff up. So now, so you've got 3, so you give her 3. And what were you holding on to? 3. 6. What number were you holding on to? 4. 10. So I get back 10, so 15. And you notice what that was. That's why this is called like recursive, or you notice what happened when we failed the other thing was a stack. It was like call stack size exceeded. We sort of stacked up calls there. And each one of us had to hold on and remember what number we had and wait until we got a value back from the previous one to finish our computation, right?
Right, that down.
Oh, we're gonna write it in code, yeah.
Can you write it like the first?
Oh, sure, yeah. Yeah, so what was happening here? Well, let me do it, let me see if I can do it here real fast in a way that'll be visible to everyone. Let me do it with 5, right? So each time I'm going to replace this, and it'll get too long to see. 5 plus 4 plus the sum of 4 minus 1. Because what I'm doing is, each time I do this, I'm replacing these values here with the previous one and sort of stacking them up, if that makes sense. Or let me make it a little more explicit here. I'm going to do this. I think it'll read more like what I want if I write it out this way. Then the sum of 4 is 4 plus the sum of 3 here. Oops. Equals 3 plus the sum of 2. Sum of 2 equals 2 plus the sum of 1. The sum of 1 equals 1. And so hopefully, let me see here. That's basically what's happening. If you're used to like mathematical formula, we can replace each one of these on up, and you could end up with this long string of, you know, replacements all the way up that ends up with just the numbers. Does that make sense?
So after you got to 1, you went back forward again. And you did a-
I think it'll make sense when I write out in code. I hope, as to how you do it. But it does take a little bit of it takes a little bit of. So I'm gonna make the function name more clear. I'm gonna say sum to n from 1 to n, and then I'm just gonna do n. So this is my function, right? And let's go back. Let's see if we can figure out how to write this together. There is, you know, something a little tricky here. So this is the algorithm. This is exactly the algorithm. Is sum of n equals 1 if n is 1. Otherwise, sum of n equals n plus the sum of n minus 1. Of course, in this case, I used a slightly better function name. So what do I want my... What's the first bit of code that we think we should write to take that algorithm and put it into code? Well, we're trying, so if this is our algorithm, if we look at this, this gets back to what I was saying. If you start to see early on in this class, there's a pattern here. There's something here that looks like we want to use one of the tools that we've learned.
So we return n plus because
That's, yes, sort of. Let's do that real fast. Return of n plus sum from 1 to n of n minus 1, right? That's what you're saying? All right? Does anyone notice a slight problem here?
Yeah.
What is it? Don't think it what? Don't think it will run?
It's not really like that.
Yeah. we don't have a case where what it's called is a base case in the general syntax. So we don't have a base case that says when to exit. So if we did run this right now, let's see what happens. Call stack size exceeded, right? Because we have nothing that tells us to exit. So let's go back and look at our algorithm again. And if we look at this, again, trying to apply that, what I was saying, this idea of you begin to see patterns and you can use a tool here. So there's a pattern here at the highest level. We say we do this or this. So at this or this, what type of tool do we have in our code to help us do something like that? What? What did you say? A while loop? A while loop is one that says do this repeatedly. An if statement is this or this, right? Okay, so that's taking this idea. That's learning how to say, let's take this, oh, I'm reading something and I see I want to do one thing or something else. My toolbox, let me go to it. That's some sort of conditional logic, like an if. All right. So what did I have as the logic here? So if n equals 1, and what do I want to do then? What's the result if n is 1? It's just 1. Otherwise, yep, else. Else return n plus the sum of n minus 1. Well, that's this line right here. Directly in the code. Let's see what happens. Then it goes ahead and runs. So we literally took, like that bit that we just did, collectively, we took that and put it almost directly in code. There's almost nothing different. The key part there is you have to have a case that eventually returns without calling the function again, right? You recursively call yourself until you don't. Until you say, oh, I don't need to call myself again. I know what this case is, and I can return from that. And then it can go back up the call stack. Does that make sense? And so sometimes there's some domains or some problems that it's easier to express stuff using that sort of recursive notation like that. Let me see what it looks like on here. I'm going to use a smaller stack. When I call this, let's just do 4, because that seems reasonable. And let's see if it can visualize the execution here. All right. Because this might help out as well. So what we got is sum from 1 to n. And let's move forward into this. So it calls it with 4, n of 4. And then because n is not 1, it's going to call it with n of 3. And then because n isn't 1, it's going to call it with n of 2. And then because it isn't 1, it's going to call it with 1. And now it returns 1 from that call and moves back up. And that one returns 3. And that one returns 6. And that one returns 10. So you notice, again, it said call stack size exceeded. That looked just like we were stacking those up, right? And that's what happens when you use something, write something recursively. So that's not something we had to necessarily teach. It's a really useful tool. There's some domains, some problems that are much, much easier to solve with a recursive function than writing it iteratively. And not everything has even like one base case. Some things have more than one base case. And sometimes you'll even call the recursive function more than once. Probably the canonical example. Does anybody know what the canonical recursive example is that's used all the time? What? Tower of Hanoi is an interesting one. I would say Fibonacci is probably the most common. And so the definition of the Fibonacci numbers, like if you were to define it, I'm going to get this wrong probably. Definition of Fibonacci numbers is Fibonacci, like fib of 0 equals 0, I think. And the Fibonacci of 1, so this is like a mathematical definition, equals 1. The Fibonacci of n equals the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So you could say, for example, if we were to do like the Fibonacci of 2, I think, get this, I can't remember if this is exactly right. I may have this slightly wrong, but that would be the Fibonacci of 1 plus the Fibonacci of 0, which, since we already know what those two are, that leads to 1, right? And that says the Fibonacci of 3 equal Fibonacci of 2 plus Fibonacci of 1. And we know what those are. That's 1 and 1. So that's 2. And so on. And this is probably, if somebody wants to try to write this, they could. I'll admit, this was probably the first recursive thing I had to write, and I probably struggled with it for hours trying to get it correct. So don't think if you can't solve it, you are really stuck and oh my gosh. But that's probably the most canonical example of a recursive function. Because it's actually, for the most part, a fair bit easier to write recursively and look at and understand what it's doing recursively than it is if you write it inside of like a while loop. That was sort of a fun concept, at least to me. I think it's a fun thing to think about. It can have dangers. You don't always write stuff recursively because you can blow up your call stack. It's usually more computationally expensive because every function maintains a whole context around it. And so every time you call a function, you haven't exited another one, you're using more memory. Whereas inside of, say, a while loop, that's not necessarily true. But it's a fun thing to play around with and work with. Let me go back to where this was, because that way I can save this as a basic recursive example and have it in the notes that way. Any questions on that? All right. That was the last thing I wanted to talk about. So I don't have any other topics. I'm going to go ahead and end the stream. Thanks everyone for being part of this, Introduction to JavaScript course for Code the Dream. Appreciate it. I meant to bring something, like I should have brought some sort of treats or something. I don't know. I'm a slacker. But we're gonna probably I'll get the confirmation out pretty soon after talking with Daisy and just getting everything lined up. But we're taking what I believe is a couple-week break before we get started on sort of the intermediate course of more connecting material between this and building out something more complicated. We'll continue to, stay connected, keep working on problems, keep talking about stuff, and just make sure that you don't let this, just stagnate over that sort of break, because that would probably be the worst case of that. And if you feel behind, you feel like you're not ready for moving on, just make sure you speak up. Come talk to me, talk to Daisy, talk to anybody, and we will work to get you, caught up in a place where you feel like you can move forward and you don't have to sort of step away because you felt overwhelmed before, because that's definitely not our goal. In the stream, and then I'll be available if people have questions about existing homework or anything else, for as long as people need it.